Hello, everyone. Welcome to another Build Prep webinar. My name is Adinda. I'm Customer Success Manager at AMIS. Thanks so much for joining us today. We noticed that there is a mix of MJF and SLS users in the audience, as well as print service bureaus. So we hope that that might spark an interesting discussion later on. Today, my colleague Chris will dive in a little bit more on our latest release of AMIS Pro and AMIS Runtime. But before we do so, I quickly want to mention there will be a Q&A at the end, so please feel free to ask any questions. There's below on the Teams menu, there's a Q&A icon, and you can ask questions during the presentation as well. And also, we'll be able to provide the presentation at the end as well. So without further ado, Chris, the floor is yours.
Right. Thanks a lot, Adina, for the introduction. And indeed, I do think we might have an interesting Q&A session today. I've seen who is in the, who's listening today. And I know most of you are actually really experts in printing and build preparation. So I hope that might give us a few interesting questions, perhaps difficult questions, but also the difficult questions are most welcome, of course. So in just 48 minutes from now, we will try to give you an update not only on AMIS Pro and what's new in the version 3.5, but also make some time for a bit of a demo, a bit less maybe than the other times, and also focus on AMIS Runtime, because from now onwards, of course, every time we release a new version of the AMIS Pro, there's also a new AMIS Runtime. And we really got to see in the last couple of months that AMIS Runtime has potentially a lot of added value for many users, not just those with 10 or 20 printers, so to say. We even see that for 1-2 printers, there might be really some interesting use of AMIS Runtime. So that's why we wanted to dive a bit deeper into that. Also with a bit of a demo. And as Adina already indicated, at the end there is some time for Q&A, but if we don't have so much time for that, never mind, you know where to find us. You can just always send us an email, or we can have a separate meeting. So let's just go for it. And I will start with, let's say, the least interesting part, maybe for some of you, and that's the behind the scenes improvements on AMIS Runtime or on AMIS Pro and Runtime from version 3, which was released at Formnext up to now. First with the one which are invisible, which are behind the scenes. There's happened a lot, of course, because as we move forward, as we implement more and more features, we also want to make sure the backend follows duly. So, a lot there that has been happening on the stability and robustness, and the reliability of the results and the accuracy. On the stability, of course, big batches do happen. We've had a couple of interesting cases with users with over 500 parts in a batch, 10 megabyte each. So batches going easily over 1 gigabyte, and of course that poses some challenges. But it was very nice to work on, and we've helped them actually overcome any issues there. By the way, not just any potential issues. It's also about together looking for potentially much faster nesting, because of course such heavyweight batches also come with challenges when it comes to fast nesting. And I must say we really made some significant improvements there. So feel free to contact us to discuss this as well. Another one was, for example, on the tessellation and geometry handling of parts. We noticed that in some cases, basically the part descriptions in the files was not resulting in enough accuracy in our parts in AMIS Pro. So we had to increase that. And that's also meanwhile doing. Now, meanwhile, you've all read through the whole text, I'm sure, but still, there's a couple of things I should mention. Right, like for example, and maybe some of you have noticed it, nesting used to continue returning results. Even when you press the cancel button, the famous cancel button, still some results could pop up after that. And we had one user who was so fast that in between the finishing the canceling, so to say, or the ending the nesting, and the next step, he already pressed save. And of course, since there was an update coming in between, that gave him another result than what he was actually waiting for. So now it's really a hard cut. When you press cancel, no more new results will be shown there. The Hang on, where was I? Yeah, there's improved slicing also definitely for the people working with the SLS machines, because there the challenges are a bit more complex. Definitely in some cases where you directly slice. So there we put a lot of effort in that. It's also mentioned there the improved SLI output, which required some back-end tricks from our side. Furthermore, we worked on the general performance, the automation. That's then mainly, of course, both of those for the runtime. Um, you can now in runtime not only quit the nesting or cancel or stop the nesting based upon a certain number of iterations, but also on a timeout. So if no result, or just take the result after X seconds, so that at least your scripts can keep on running while you move forward. We have a full Mac support. According to some people here in the office, a Mac is a real computer, and all the other things are not worth that name. But let's not discuss on that, because most of our users actually use just good old Windows computers. We also have the improved licensing handling, and that you may have noticed, of course, because it's really easy for us to, from a backend, indeed update your license if needed, or just extend your trial license if you're still working on a trial license. So that has become a lot easier, not only for you, also for us, for that matter. What's something that we keep on working on, something that we keep on maintaining, is of course the testing protocols, continuously updated, just as well as the continuous integration and continuous deployment improvements. And that's, I would say, mainly due to the fact that we have a team here in development, people that have been deploying industrial software for over 25 years. Yes, we move forward, and we move forward very quickly, but none here in the development team will forget about this backend things which need to support this further development. So it's quite some effort has been going in that as well. Now, probably more interesting for you is the front end developments, the things that have been changing within AMIS that you will immediately notice. And first of all, and by popular demand, I would say, as most of our features, has been on the orientation control. And I will immediately just show what I mean when doing that. So I'm quickly making a new batch, adding some parts into it, and there you go. Of course, well, I'm very much used to rotating parts by using the shortcuts and Alt X, Y, Z to rotate those. So that just gives me, in this case, a 15-degree shift each time. But a lot of people also use, when I double click the part, I go into the part view, also use this one, whereby you can rotate using this gizmo here. That used to be fixed, meaning the gizmo rotated together with the part, and in quite a few cases that was a bit confusing. So we changed that, meaning you now have the gizmo which is going back to 0 as soon as you let go of the gizmo itself. That results, of course, in a 0 rotation here, because compared to the gizmo, there is no rotation. So that might be a bit difficult at first sight, but you can always just reset now, and that's the other improvement, the reset button there, to just start from 0. Now, most of you also work with incremental rotations. So again, if you hold the Alt button, you just go up or down with the Alt. If you hold the Shift at the same time, it goes in the other direction, by the way. So this angle, with me, it's set at 15 degrees. I'm now in the settings here in the configuration. You can just as well, of course, set it to 30 degrees, 45 degrees. I know some people who put it exactly at 23 degrees. So it's just as you need it. 15-degree angle. Don't forget to save here, by the way. And you can also just zoom in and out in this field or in these types of fields so that you have the save button visible at all times. What many people don't realize is that it's also possible to just select multiple parts, either with Shift or with Control, so that you can skip one, so to say. And then again, by using the Alt button, you can just rotate those simultaneously or at the same time, which is quite useful. Definitely, for instance, if you're in the, let's say, insole business or dental implants or things like that, because quite often it's all parts coming in the same way, not necessarily the way you wanted it. So then you just select all of them. By the way, Control A to just select all is also an option. And you want to rotate them all together. Otherwise, it's going to be a long process doing that one by one. So there are some improvements on the rotation. I think that really makes life a bit easier for a lot of people. Here the quick top views and side views of the parts, which works in the batch view and in the part view as well. Of course, also makes it easier to get an immediate view on your batch from a certain angle. We also improved the working with the builds. That's already quite a while ago. I think it's been in for a couple of months already. So let's now just nest this. There we are. They're all in. Imagine the batch is nearly full, but you're still waiting. You're happy with this configuration, with this nesting. You just want to add some parts later on top. For example, when a last minute order comes in, that's no issue. Of course, you just lock all. Everything inside the build box is locked now. And then instead of adding a new part, I will make it easy for myself. I will just duplicate one. So now I can just easily nest that part without touching the others. So if I nest it now, it's just nested on top, or if there is still space somewhere behind the other parts without touching the build that you already prepared. Another one that you may have noticed in the last couple of weeks is that we kind of changed a bit here on the printer settings and made it easier there. Apart from a couple of improvements on how it looks in general, we actually connected the output settings of the printer to the printer itself. So in this case, it's a mesh-based 3MF file that is the output, which means you don't have to choose this anymore whenever you output that batch. So imagine you're happy with this batch, you're gonna want to print it. You just click output, and then immediately it's gonna choose this 3MF file as an output. If really needed, you can still overrule it by here changing the settings, but I suppose normally one printer has one type of output. So that's just, again, a couple of clicks less, a couple of less possibilities to make a mistake there, and that's of course what we all want to achieve. Right, the next one, the multi-copy handling, I did show it, and so you rotate multiple parts at the same time, which makes it much easier. Definitely, if you have a lot of similar parts. The collision check, of course, that's an important one as well. I think we installed it here. We got here this collision check, which you can just press and then it runs through. Now, important to know, the algorithms of AMIS do not generate any collisions. So should not never be an issue. We've never had those issues in the first place. But of course, it is possible that if you say like, okay, I'm still rotating a part here. Oh, of course, I locked all, so I need to unlock first before I can actually rotate it. So let's rotate this one, and then maybe I moved it a bit, and then of course I didn't notice it or I forgot about it, and then it becomes relevant to have this collision check. You get a warning, and the parts that are actually affected are colored red, so you know what is wrong there. By the way, in the configuration, again, in your settings, you can enable this collision checking with every output generation. And it usually only takes a couple of seconds. So it might be an interesting idea to anyway have this enabled, and that you have an output check or a collision check on each output anyway, that just taking away any possible mistakes, so to say. So then it wouldn't even be allowed to export this one. If I output this one, I can try to do it, but it will give me again this warning saying like, oh, there's something wrong there. Right. So that changed also there. Yes, a lot on the reporting side. Not only inside here the UI, where we improved a bit on the nest density graph. Sometimes there was definitely with a renest, there could have been a mistake there. So that's out now. That we got a sound density overview here. And this one looks much nicer, of course, if I have the layer density enabled in this print. So that one changed, but also, and that's for many people, and definitely for people who are looking at using AMIS Runtime, we added a lot of possibilities here to add data into the export file. You can still export as a CSV file, and there you got all the usual data, the parts, the part dimensions, the part volume, not only its boxed volume, but also the printed volume, and even if it's hollow, the volume of well, let's say what is really hardened out in the printer. But and the number of parts that actually have been put inside the batch. When you select a JSON file as an output, you have much more options actually to include in that JSON file. And all those options, of course, is data which you can use not only for your ERP or MES system, but of course also when you're building scripts for AMIS Runtime. And I will demonstrate this a bit later. So there quite some improvement in there, let's say. Furthermore, some usability. Oh, that was too quick. Usability and feedback that has improved. Some of you may not know this, but actually you do need an internet connection to run AMIS Pro, but not because any data is sent over, not because we're reading any files, we're seeing what you're nesting or anything like that. That's also, by the way, mentioned in the conditions in AMIS Pro. But it's just, of course, that we need some check on whether your license is still valid, whether you're actually using AMIS Pro as it should be used. So that's the only thing we're checking there. By the way, if you really need something which is offline, come talk to us. We can definitely have a look at how to solve that. But for now, the basic version comes with a check. Of course, you need a warning if you're not connected, so that at least you know what to do to get AMIS Pro up and running. We did a few UI fixes. For example, on the printer list navigation warnings, whereby if you don't fill out all the data, that you get a warning like, hey, we still need this data in order to activate your printer and such things. And the non-nested parts used to be sometimes invisible behind your build box, but that has been solved now as well. Right. One that many people have been waiting for is, of course, the adding the labels to the boxes. So, of course, we can box parts. I now just took this one. As most of you know, boxing the parts can either be freeform or square ones, the square boxes. Freeform, of course, taking less space, and actually being quite just as quick as any other. So I think in many cases, people might actually consider to use freeform, and they're more used to the square ones, to the cube shaped ones. So might be something to discover there. You can either do an automatic box calculation, meaning that the size of the holes is calculated automatically so the part can't fall out. Don't worry about that. But of course, in some cases, you might want smaller holes so that, well, there's maybe not an antenna sticking out or something else sticking out, so to really make it safe. So in that case, you would choose manual, just say how thick the beams should be, how big the holes should be, and go from there. And so now you can just add text here to that part, execute the boxing. There we are. And then typically, by the way, I will double click here. Typically, by the way, no, not if you rotate it. I just rotated the part. The label will be put on top of the part so that it's easily visible. We thought also if you actually unpack the parts, the top is the first thing you see, so it might be useful to put it on top so you immediately know what part you're looking at here. So that's dealt with now. That's something you can use now as well. By the way, and that's something we're still working on, but it might nevertheless already be interesting for quite a few people. Here again, you might want to zoom out a little if you want to see immediately all the details. You can lock position on a per part basis so that it's not touched when being nested. You can move around the parts by just using the arrows over here. Of course, also by entering data directly here in these boxes. But you can also just use these boxes to then use your arrow to actually move parts around. So if I just tap here, there it goes. I move it up. I alt tab. I move it around. So there you can actually just move it into position quite accurately by moving those arrows. Maybe not so important, but nevertheless could be interesting. If I move a part out, then actually if I go here below 0, it goes out again, and you remove it from the build box, so to say. Okay, just to support that, a small demo, as I said, a small one this time. I'm not going to go into nesting strategies and different possibilities, just going through a couple of cases that might be relevant for you. First of all, let's, of course, that's one we encounter quite a lot. Everybody of you who is printing in SLS, you know about the no build zones, and of course, people want the no build zone, and just to make it easier, not to have to put it in there each time. Now, there's a very easy workaround, of course. Instead of making a new build box, I will discard this one, selecting your printer here and the EOS, let's say, there it is. In just as many clicks, you can open an existing printer. There we are, in which you actually already installed that no build zone. And I think I didn't lock it in position. There we are. So now I locked it. So each time that you restart, instead of clicking this new, you just click open and you go back to that same old file, and your no build zone is in immediately. Hang on, I will just open another one here where I actually had this batch prepared, and there we go. Okay, as is quite often the case, you might have many different parts with many different quantities. I did prepare the quantities here, otherwise I would be just entering data, or I would just take it either from Phasio, where I can have a CAMSPEC export and have all the data already inside, or I could just script it, of course, in runtime, whereby I also wouldn't have to do that work. But now, for this case, I just entered the data here. As I indicated before, all these parts are lying flat, which is probably not the most interesting way to put it. So I will just select all parts that I want to rotate. Of course, I know the last one is a big one, and I will rotate them immediately at the same time. So there you go. Give them a 30-degree angle upwards, so they are ready to nest. There we go. Then I have this very big part here, which is a bit inconvenient because I can't really see if it's fitting inside my build box or not. It's far away. I could, of course, shift it over here and then start working on it, but it's, yeah, could be a bit inconvenient. Now, what you could then also consider, just making your life easy, of course, is that you select that part and you're going to prioritize it. So now it's prioritized. If I click now nest, everything is put in there, but I know for sure that my drone wing will be in because my drone wing was prioritized. Of course, what always happens at a demo is that because I've got so many things open at the same time that the nesting is a bit slow. Normally this is just a few seconds. So there's my prioritized part. I'm sure it's inside, which means if I want to, I can now just lock it and clear it like that, and then I've got it already installed in the middle of my build box. Without the talking, this just takes 2 seconds. With the talking, it was 1 minute. But just to show how you can go about it. Now I will actually unlock it because I'm still not happy with how it's positioned. So there we go. I will still give it a bit of a turn like that. And let's see, I can move it a bit over here. Well, I can move it, of course, in the 3 different ways, like explained before. I could just enter data here or just move it about here. There we go. That's just which works a bit the most, or which is the easiest for you to work with, of course. However, another trick to get something in the middle could be that you use here the max layer density nesting. A normal nesting starts always from a corner. So it starts nesting in a corner, seeing what else it can add to that specific layer. The max layer density, so which is the algorithm that will actually reduce or limit the density for each layer inside your build box to that given percentage which you've entered here. That one starts from the middle. So if I have a prioritized part here, because it is prioritized, it would automatically be placed as a first, and it would automatically be placed in the middle. So let's see if that's a bit true, what I'm saying here. There we go. Again, a bit slow. I will cancel here, and indeed, there you got it. The part is in the middle, so it's centered around this point here, whereas the rest is neatly moved around. There was another one here, which was a labeled box, but we've noticed that one before. So the basic point, I think, of this very brief demo is more like play around with it. And in the previous webinar, we talked a lot about nesting strategies. You can still find it on YouTube, by the way, where I gave more demos on playing with this. But it's with a better word, it's called nesting strategy, of course, and it's really something that we encourage really to try new things, see how that works, get to know your algorithms, because that's really allowing you to move forward and to come to better nestings in a much faster way, I think. Let's just have a look at the density here out of curiosity. As we wanted it around 15%, it is neatly around this 15% indeed. Okay, you all know probably also that if you want more demos, you can find them online, but you can just as well contact us. We will be glad to give a specific demo for your case, for your machines, and even if you provide some details on your batches, we will be very glad to look into your batches and to look into your challenges, so to say, because also there. I talked about the installs before, about the dental applications before. Quite often these specific batches come with specific needs or requirements or challenges, and we already have a bit of experience, of course, in finding the best way. So please drop by to discuss those. I'm quite sure we'll find a way around. Good. Now, as announced, that was AMIS Pro. Now looking into AMIS Runtime, and I'm not having a software background, so for me it was also like, oh, scriptable, automated sounds difficult, and it sounds high end. You need a lot of experience for that, etc. But really, we got to see more and more how easy it is and how much it can weigh or how much it can make a difference on the total cost of ownership for your machines. And that has a lot to do not only with the number of machines, but with the number of batches that you have to make. And so basically with all the parts that you have to nest inside those batches. And what we see now, if you have if you just nest on a batch level, of course, and the person doing it is going to try hard to fit in as many parts as possible, but he can never have a full overview of that entire backlog, a continuously changing backlog for that matter. So he's kind of forced to make decisions at some point in time and prepare them and finish them and send them to the printer or anyways save them somewhere. And he doesn't want to touch it anymore, logically, because otherwise he's again wasting time. So that's suboptimal in many ways. And it's labor intensive, and there's quite often a bit of repetitive work in there. So if you can actually look at the whole backlog and start looking into that as to not only prioritize parts, but prioritize entire workflows, that gives a lot of opportunities. And we want to break it down into two ways, let's say, or two steps maybe. Because already, if you use AMIS Runtime on a very basic level, it can already generate a lot of benefit, we believe. That's just, for example, those things you anyway have to do, the work you anyway have to do, which otherwise takes time, which is not difficult necessarily, but yeah, just takes a lot of your time. And there you could just say like, okay, if I have some script that just imports the parts and nests them according to certain rules, which I will give to that system, certain density, certain gap distance, etc., etc. Just nest it all in there, and we'll afterwards see what we do with the parts that didn't fit. That's also fine. Then you can already start as an expert in basically preparing batches. You can already start from something which is pre-optimal, which is almost optimal, but it will still require you to have a good look at it, maybe do a renest, maybe rotate some part which isn't in the right position, etc. And that will already give you a certain benefit. Now that also means that from there you can, for example, look one step further. If you have a big part, if the algorithm will put it in the corner, it's not so difficult to say like, okay, if a part is bigger than X cubic centimeters, then you just tell it to the algorithm. And nowadays with the AI, you can get quite far in that. If the size is bigger than this, then position it in that location, which means, well, it's just mathematics, right? It's just X plus Y, and you put it there. So that already, you see it coming. It can easily move forward in real automation, in real next steps. But basically, this first step is focusing on just getting better batches faster. And that could be just a very easy flow. You got a place where the algorithm or the script goes get the part, you put it inside a batch with your nesting requirements, an operator reviews it, and then you just send it to the printer. Now, it really gets interesting, of course, if you stop looking at just the batch, but at your entire workflow. Meaning you can really start looking at making perfect combinations of, I would say on any level, not just how to say, okay, part size can be one of those. And of course, you want the big parts in the middle and maybe not at the bottom, at the front, but depending on the technology, I know you want them in a certain position anyway. But also, hey, wait, I want my system to take into account that I have different printers, that I have different materials in different printers, that some parts need other post-processing than others, and that some parts are more urgent than others. So meaning you would prioritize the parts that need to be delivered tomorrow, and you would put the same material in the same batch, of course, etc., etc. You can also start thinking on a batch basis, like, okay, where should they be positioned? Can I find a rule to actually put a certain gap distance in? If part is bigger than X, then make me a bigger gap distance. Or if my part is a drone wing and very flat and very thin, I also want more distance from the side, and I want more distance from the other parts, definitely if they're big parts, etc. But those are all scriptable things. Those are all things that you can say to an algorithm, do this or do that. And then, of course, that really allows you to not only look at today's parts and what needs to be in today, but then have maybe 5 batches, which are pretty good. But then yeah, only by looking further, you can actually start filling up those batches, which are maybe at 8%, and you want to go to 10%, with smaller parts, which were foreseen for day 7 or 10 or 12, and you add them into those batches, which will of course allow you to go much higher in densities, which will reduce the number of batches that you actually have to print. You can, of course, also use those algorithms then to calculate pricings, not only just on a volume of a part, which is happening quite often now, but also on nestability of parts. How many can I really get in? And that's like a 2-second operation in AMIS Pro, I would say, for most parts. You can do auto rotation of parts or give a rotation to parts depending on what they look like. And of course, you can continuously renest. New part comes in, new order comes in, you just renest everything. It doesn't hurt. It doesn't take your time as such. The density wasn't reached, or there were too many parts in it, no problem. Just if the density density you aim for wasn't reached, you just let it calculate other flows or other possibilities, etc., etc. Now we know, of course, that at all of these printer OEMs, they have their own, let's say, nesting rules, their own ways of which they know is the best way of nesting. Those are the things you can also start translating, of course, in something like AMIS Runtime in your own scripts, combined with, by the way, your own IP, because basically it can be a translation of your knowledge, your expertise in nesting into algorithms, which allow you to, well, just get out better parts than anybody else, so to say, or more parts than anybody else. So this is something we strongly believe in. I think any workflow that you make in it will, of course, have an analysis bit. You will analyze the parts. You will prepare the parts, maybe rotating, give them a certain gap distance, give them a distance to the wall, give them a certain position, maybe in some cases. You will generate a batch. You will evaluate the batch, and there you got, of course, a lot of possibilities for loops, for going back, doing something with the result, selecting a certain result, and then release certain batches for print, taking them out of the backlog, and basically, printing those. Some examples underneath there, you could, with thin parts, detect that those are thin parts. You could assign gap wall to them. You could position them, etc., etc. With very small parts, you could say like, okay, automatically box them with these and these settings, etc. So it's quite limitless when it comes to opportunities. Now, that also means that this workflow, which is, I think, still a relatively limited workflow, can grow as you get to know the possibilities more and more, and also to fine tune your own scripts to actually come to the perfect batches, so to say. And that is, of course, also because you can really analyze your results. You can then go through your processes again if you're not happy with the result, and like that really save a lot on your printing. Now, AMIS Runtime is not some idea. It's installed, it's operational, it's fully documented. So we got people working with this. And it's mainly because we believe that not only the real big print service bureaus can benefit from this, that we wanted to stress this in this on this occasion. By the way, it's also being released, thank you, Adina, on GitHub earlier this week. So that's where you would get all the code, where you would get the documentation, where you would get the example scripts actually. So that would really give you a head start. You should know, however, that of course first you need to download AMIS Pro, although they can run separately. But you get AMIS Pro, you get a license when you get AMIS Pro, and then yeah, if you call us, I would say, or if you contact us, we can upgrade your license to a runtime license, which allows you to get started with this details in GitHub. Right. So what we see now is that AMIS runtime really improves this cost per part, TCO, cost per build, and per operator hour because of the examples I gave before. Now with a typical mixed batch, so big parts, small parts, bit of everything combined, we see built well, not only higher density, but basically a reduction of what needs to be printed, the number of batches to be printed, up to 20 to 30%. Of course, that's not possible when you're looking at insoles only. Again, it's a very good example. When you only have insoles, they almost all look, well, they look very similar, right? So the possibility that you actually have a better match with another insole is a bit smaller. So there we do see gains, 5 to 10% approximately, but of course not as extreme as with the mixed batches. Now, 5 to 10%, if you're running daily prints, that really makes a difference at the end of the month, of course. Imagine you're having 10 or 20 batches a month, then already 5% is one batch difference. Now, basically avoiding, as it says there, avoiding one build per month covers your investment in runtime already, and actually more than that. So that's what we're looking at. That's the possibilities we're looking at here. By the way, we know it's not always easy to get started. We will anyway support you in that. We call it here 4 hours consultancy free. Yes, that's it. Because then we just go a bit further than giving you the advice, so to say. We will really try to get you up and running with that. But of course, the IP will come from you, and I think that's the big advantage there. I only have very limited time left to actually show what it does. By the way, these are my scripts, and that was actually created all with AI. As mentioned before, I don't have any experience in development in software, so I did this in a couple of hours because now it's an upgrade from another one that I showed before. Just using AI. And putting a lot of effort in that, not in actually learning how to code. So I made this UI. No, I didn't make it. I had it made by AI, saying like, okay, I want to run nestings according to certain settings here, and I want them to keep into account the delivery date. So batch me everything and yeah, go from there. Okay, configuration is saved. Start nesting. Yes, go ahead. There goes my main script. So what it basically does, I got here 63 or 68 parts listed, which gives me the details of the parts, such as, and I think it will, oh yeah, it does open here. The quantity, the rotation, X, Y, Z, whether it needs to be shelled, if it needs a specific gap distance, and what the due date is. Of course, due date here is just a figure. That's easier for demos, right? So it will just keep into account those delivery dates and start creating batches for me, which should be dropped in my out folder. Well, there, number one is ready. I'll just close this one. So my first batch is ready. Automatically generated. And I also asked the algorithm to create a JSON file. That's my number one. To create a JSON file with all the details in this. Now, this is not exactly an optimal build, right? It looks quite dense, and it's anyway not using the full build height. But let's just continue it rolling, because in total it's more than 10,000 parts over about 10 different batches. First results are in. I clicked here the analyze batches. So the fill rates are quite low. The density is reasonable still, but anyway, it's not an. So we gave it a status underfilled, which is of course just a name. You can give your underfilled rate can be at 80% or 90%. It's just as you how you script it. I will analyze my batches again, and I will not take it too long because I'm taking away your Q&A opportunity, of course. But the basic idea is that I've got now 10 batches just by spreading them according to delivery date. And that's a bit extreme. I know it's not a perfect batching, and most of them are underfilled, so that's not a perfect idea. So I made a second script, which is actually I will save this one and start nesting, which is basically not only taking account the delivery date, but indeed looking at the entire the entire workflow, every part that is in there. And then, of course, starting with everything that needs to be delivered on the first delivery date, but adding parts, if possible, from later delivery dates. Still, by the way, dividing the parts according to size over the different batches so that you don't have one batch which contains all the big parts and then one batch later maybe all the small parts. So it's really dividing the big parts over the different nesting so that you got a nice mix, of course, which has a positive impact on the densities. And so on and so forth. I would say analyze batches again. Okay, so the new results are coming in, which is much higher fill rate, which has an overflow for which I made this optimization workflow, by the way. So it's still okay. But I hope it already gives an idea of how far you can go with very limited means to basically have an optimization and a serious optimization of your total cost of ownership of your cost per part with this solution. So afraid that I'm actually really taking away. No, let's take one last look. Okay, so these are okay. I've got one with an overflow. I will return to my presentation, allowing you basically to still ask some questions. The pricing, most of you, I think, already know. You can find it online. It's just together with the software on the software page. And of course, we have discounts if you have multi-year or multi-seat orders for that. So I would say, finally, the word is up to you. Adinda, did we see any questions coming in?
Yeah, thanks for, first of all, Chris, for the lovely presentation. Indeed, now it's up to the audience. You can, oh, yeah, there's a first question coming in. Do I still need Streamix? Am I pronouncing this correctly?
That's a good question. No, you won't. Basically, it's yes. This is the replacement, let's say. So yeah, no need there.
Any other questions
Yeah,
from the
please do
audience?
ask your questions. This is the right time, I would say. Also because maybe other people in the audience can benefit from your answer. Oh, I do see.
We have another question. Does runtime show builds on a Gantt chart?
Yes, I see what you mean. Runtime is backend. I mean, it's not going to show you anything unless you tell it to show something. So it would not be. Maybe I should make one for next demo. If you connect a certain duration to the certain print time for a certain build, you can actually just take that over on a Gantt chart and just tell your algorithm, tell your script to create a Gantt chart, taking that into account. So that wouldn't be too hard to do. Actually, that's really one I could do myself. All right.
Another question coming in, does runtime require JavaScript or is it Python supported as well?
It's a node script, by the way, and all the details are in the in on the GitHub folder there. it's from what I understood, it's quite similar to Python. Anyway, we can provide, if really needed, we can provide a Python as well. And we're definitely also willing to look into other needs if that would be the case. We know one of our users is actually running it on Python. And basically, in 2-3 minutes, he had the Python code generated from the node code just using AI. Uh, and he's very knowledgeable on IT, but still he had AI do the dirty work, so to say. So Python is definitely an option. Right.
Can runtime keep up with 50 plus MJF printers?
Yes, you might at that point. It's a very interesting question because we have users that are talking about letting runtime run all night, and in the morning they expect a result. So they give it hours and hours to do recalculations and really go optimal, let's say. We have other users that actually want to use it to have a result in just minutes for all batches. Now, in the latter, of course, that means upscaling on the hardware, perhaps, or that means upscaling on more runtime licenses, because runtime can run one operation at a time. But so yeah, that's an extreme case. That's indeed difficult if you only allow it to calculate for a few minutes or 1 minute with 50 MJF printers. So it depends a bit on your needs, how many runtime licenses you would need. But basically, it's not an issue. It's just about calculation time. It's just yeah, and of course your script will need to keep into account that it's actually working for 50 batches at the same time. But there is no issue. I was just creating 10 batches at a time, and it was, as you may have noticed, in minutes that they actually came out. I can show it here. This is what I just created. So 7 batches in total. It started running at 5:16. It was finished at 5:17. Okay, those are not the big batches, but still, it demonstrates the possibilities. I think. Okay. Do we have any further questions?
I think we are good. I don't. Oh, there's one more.
Okay.
Okay, so as a sequence to the previous question, so those are 10 separate builds question.
Yes, indeed. So where was I? It's here in my runtime cases, generic, in my out folder. There they are. You see that they all are a bit different in size, because they are divided and they're not all, yeah, the same part in the same batch, so to say, and that copied 7 times. That's not what it is. It's really making a smart division of all the parts so that it's optimized throughout. And I believe they were nested with a, yes, max layer density of 13%. So that means that at the same time, your density will also be okay for this, well, in this case, I think MJF, and all 7 or 8 batches are different, with the same settings depending on what you need. Right. If there are no further questions, I think, well, questions are anyway welcome. I said before, they are welcome anytime. So please feel free to send them over to go just in another meeting with us. We'll be glad to. Furthermore, we will be, these are a bit of key takeaways, let's say. Oh yeah, also do contact us for the tough batches. If you think like, oh, this is not working the way I want it, we can definitely have to have a look at it together. We'll be glad to. You also find the runtime download pages also for the AMIS Pro download. By the way, we have a German website up and running now. Soon other languages will follow. And we have a German white paper on nesting with a lot of information on nesting in general, which will also be translated then to English in the coming months. We're traveling. soon Adina and I will be in Birmingham for the TCT 360 there, so we will be very glad to meet you there. I need to be in Singapore in September for the ISO meeting, of course, related to additive manufacturing. So if you happen to be around, glad to talk. We can be anywhere. If you have a certain suggestion to meet a certain place, we will be glad to. And of course, we'll be at Home Next by the end of the year. Online, you can reach us anytime, and we'll be glad to help you. Adinda, did I forget anything?
So sums it up basically.
Okay. Well, thanks again for joining today. Very glad you were here. Do feel free to contact us. We'll be looking forward to hearing from you. Thank you. Bye.